Hi, science friends. Today is the last lesson of this unit, and it kind of seems to be just thrown in here a little bit. The electromagnetic waves, that's something that we have to important that we teach. But it's important in this unit because it has to do with electrons. And so all waves and all light is an example of an electromagnetic wave. We see light, we have these particles that move, and we can transmit information because of the movement of electrons, and that's what we've been talking about lately. Electrons and periodicity was this unit. So in the electromagnetic waves, light is one of those, but we have what's called the electromagnetic spectrum or electromagnetic radiation. And so on the electromagnetic spectrum, there are 7 types of waves. 1, 2, 3, 4, 5, 6, 7. And there's a mnemonic for these 7 so that you will never forget them. And it is Roman, men, invented, very, unusual, X-ray, guns. And so that stands for radio. Men stands for microwave. Infrared is invented. Visible, that should say visible, sorry. Ultraviolet, X-ray, and then gamma. Those are the 7 types of electromagnetic waves or electromagnetic radiation on what we refer to as the electromagnetic spectrum. And we'll talk more about that in just a minute. Okay, so one thing that's important of electromagnetic waves is in a vacuum, they all travel at a specific speed, 3 times 10 to the 8th meters per second, which is the speed of light, sometimes denoted as the letter C. Okay, and we'll do some calculations with those in a minute. So one of your assignments today is going to be in drawing waves. You have one of your pages says anatomy of a wave, and you're going to draw some waves. So that's going to use this part of the lesson. So when we look at a wave, you have a height, the height of the wave. And so that's from crest to trough, this height from the crest of one wave to the trough of the next wave. Okay, and that is referred to as the amplitude. It's the height of the wave. Okay, you also have the wavelength, and so that's from a crest to the next crest, or you could also measure it from the trough to a next trough, and that is the wavelength. Okay, signified by this letter, that is the Greek letter lambda. Kind of looks like an upside down Y. But that is the wavelength of a wave, okay? And then you have the frequency. So what the frequency is the number of cycles that pass in a given amount of time. So it's usually measured in cycles per second, okay? So if you think about like, sometimes I like to think about like a jump rope, okay? If you shake a jump rope and you shake it really fast, you'll have more ripples in 5 seconds, right? If you shake it slow, the ripples will be longer and you won't have as many of it, okay? So this is a high frequency wave. This is a low frequency wave, okay? If it took 1 second to make all of that, you did 4 cycles per second, versus this one only did 2 cycles per second. Okay, and that unit is also referred to as hertz, which is Hg. Okay, that frequency stands for the letter V. Okay, so these are inversely proportional, meaning if you have a high frequency, you have a short wavelength. This wave is short, okay? Versus, I'm sorry, wavelength is going to be here to here. Sorry. You have a short wavelength. If you have a low frequency, like in this wave, you have a much longer wavelength. And so they are inversely proportional. Okay? Sometimes we do calculations with these. And so wavelength is lambda is equal and times frequency equals c, which is speed. Specifically in this equation, it's speed of light. Okay? You could just say speed of anything though. Speed equals wavelength times frequency. Okay? Speed equals wavelength times frequency. So in our problems that we're going to work today, you'll use this formula because you won't be calculating with speed of light. But speed equals wavelength times frequency, or you can use S for speed, would be fine. Okay? Whatever. All right? So let's move on. So here's our electromagnetic spectrum that we just talked about. I'm going to mark off the broadcast band and the radar here. Those are kind of extra added in. But you see our radio waves, Roman, men, invented. This is the visible part that's dropped out here. Vary. This is the visible light spectrum. Unusual, X-ray, and then we should have the cosmic or gamma are the same thing. Guns. Okay. Roman men invented very unusual X-ray guns. I probably should have picked a different picture that didn't have these extra words in there. But you see, the visible light spectrum, what we see as far as colors, falls in here in sort of the middle. Okay. So our long waves are down here, 10 to the 3rd kilometers, versus our short waves are down here with the gamma. These are going to have the high frequency. And then as we move down, we'll get a little bit longer frequency. And then we'll get a little bit longer frequency. And then as we get down here, we get an even longer frequency. And so this is a spectrum, okay? Here in our visible light spectrum, you have those colors of the rainbow that you know. Red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv that you know. The red being the longest wavelength and the violet being the shortest wavelength. And so each color in the spectrum has a specific wavelength and frequency that it's associated with. Red's going to have longer waves, okay? Meaning it's going to have a shorter frequency, okay? Or a lower frequency. The violet is going to have shorter wavelengths, so it's going to have a high frequency. Down here we're going to have low frequency, okay? So that's the visible light spectrum on the electromagnetic spectrum. Now, different gases or elements produce what's known as the atomic emission spectrum. And so certain gases can be characterized by or identified by their emission spectrums. So if you take an unknown gas like this, and you characterize it on an atomic emission spectrum by looking at its excited electrons in what's called a spectrograph, done by a machine called a spectrophotometer. You see here these little, emission lines at certain wavelengths. And you can look at this unknown then, and then compare it to these, which are known, and determine what your chemical is. So what chemical does this match up to? Well, you would say that unknown is strontium because it has the same emission spectrum as strontium. Okay? All right, let's do a few calculations with our problem. Remember, we've got speed equals frequency times wavelength. Okay? Speed equals frequency times wavelength. And you've got some of these to do on your assignment today too. So, calculate the wavelength of the yellow light emitted by a sodium lamp. If the frequency is 5.10 times 10 to the 14 hertz, okay? Now for this one, because they didn't give us a speed, we're going to use the speed of light, which was 3 times 10 to the 8th meters per second, okay? If they gave you a speed, because it's asking you something different about a wave speed, then you can put in the wave speed that would be given in the problem. So for this one, our frequency is 5.10 times 10 to the 14th, and we're trying to find the wavelength, okay? So what we're going to do is we're going to take 3 and divide it by 5.1, which gives me 0.588, and then we're going to subtract our exponents. So when I divide this 3 divided by 5.10, I'm going to have to take 10 to the 8th minus 10 to the 14th, so it's going to be times 10 to the negative 6 would be that answer, okay? Or if you wanted to express it in proper scientific notation, it would be 5.88 times 10 to the negative 7, and then the wavelength is in a unit of meters, not per second, meters, okay? Meters. Let's look at the next one. What frequency is a radiation whose wavelength is 7 times 10 to the negative 5th? Okay, so we're solving for frequency. So for that, we'll do speed over wavelength. The speed is that 3 times 10 to the 8th. And the wavelength is 7 times 10 to the negative 5. So when you divide that out, 3 divided by 7 is 0.43 times 10 to the 8 minus negative 5 is going to be 8 plus 5, which is 13. Okay? 0.43 or 4.3 times 10 to the 12 would be the proper way. And this is a frequency, so we can express it as hertz. Okay? Again, some of them may give you a different speed on your assignment today to plug in instead of 3 times 10 to the 8th. Okay? I also believe there's one problem that I think it's maybe the first problem. I think it says times 104. It should be times 10 to the 4th. That should be an exponent rather than a 104. Okay? So make that note as well.